operations and solving equations. When you're going to solve an equation or do an operation, that there are lots of these things that look different than you may have seen in traditional classes. And I'm not expecting you to master it, but I want to make you aware of it. So that if this is a door you're interested in walking through, you at least know that the door is there. So can you remind me what an operation on a set is? And think something where you have two things from the same set, and we combine them in some way to get something else, or maybe the same thing, from that same set. So we have two things that live in a set, and we combine them to get something in the set. Now, when we say combine them, that doesn't mean necessarily that we're adding. So for instance, an example of an operation on a set is you can look at addition on the integers. So whenever you say, I'm doing this operation on this set, you have to say what the operation is. So how this works, when you have two things, you want to add them to three things, you just push them together, and you get the total number of things that there were. And so we can represent this in some symbols involving numbers, but this represents a physical thing that's happened. These numbers represent physical quantities that, and this operation represents what happens when you push two piles together. But they get much weirder. For instance, we saw another operation called XOR, which was defined on binary strings. So can you give me an example of a binary string? So I have 1, 1, 0, which is one binary string. Can someone else give me another example of a binary string? So we XOR these together, and all we do is just go through 0 XOR 0 is 0, 1 XOR 1 is 0, 1 XOR nothing is 1. And so I have two binary strings, and I combine them to get another binary string. So XOR is an operation on binary strings. Would you like to do another one of these to feel more comfortable with it? Or so you know you get the right answer? So I would like for you to try on your own another XOR problem. 1, 1, 0, 1, 0, XOR 1, 0, 1, 0, 1. Remember, the basic rule here is that you do 0 XOR 0 is equal to 0. 1 XOR 0 is equal to 1. 0 XOR 1 is equal to 1. And 1 XOR 1 is equal to 0. And these work the way you would expect for addition, except that when you hit 2, you just start over at 0. So here are our base rules. And then when we want to do these element by element, we're going to combine these. So when I 0 XOR 1, what would I get? No, 0 XOR 1 is 1, right? It works just like addition until you hit to 1 and 1. So what would 1 XOR 0 be? 0 XOR 1, 1 XOR 0, 1 XOR 1, 0. All right, so I want you to do this one completely independently. I'd like for you to try to do 1, 1, 1, 0, 1, 0, XOR 0, 1, 1, 0. So what do you have here? Yeah, no, you can start at the left. That's fine. 1, 1. 1, 1. So 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0, 0 XOR 0 is 0. Now, those are two examples of operations. Another example of an operation that you can do on binary strings or on words is called concatenation. So concatenation, which I'm going to write as cat, you just take the two strings and you literally merge them into one string, just smash them together. So 1, 1, 0, 1 concatenated with 1, 0, 1, 1 would be equal to, now just take this first one and write it, and this is 1, 1, 0, 1. Then I take the second one and write it, 1, 0, 1, 1. I've taken two separate binary strings and I've made one binary string out of them. I copy the first one, I copy the second one, I write no spaces between them, and this is a new binary string made from the first two. Here's another example of an operation because I'm taking binary strings and I am combining them to get a new binary string. So what would cat of 1, 0, 1, 1, 0, 0, 0, 1 be? Now, are y'all okay with this? But I could do concatenation and XOR together. Could I do something like, I want to do this calculation of cat 1, 0, 0, 1, 1, 0, XOR cat 1, 1, 0. Is there any reason I can't? So let's first compute what cat 1, 0, 0, 1, 1, 0 is. I get 1, 0, 0, 1, 1, 0. Now I'm going to be XORing and I get 1, 1, 0. And this is something where it's 1, 0, 0, 1, 1, 0, XOR 1, 1, 0. So how many ones will be in the final answer here? Take a minute and look at this. There's only one. Yep. 0 and 0 give me 0. 1 and 1 give me 0. 1 and 1 give me 0. 0, 0, 1. So this would be the final result of this calculation. Now you may wonder why anyone would do this. Well, when you think about how you're making a cipher, what you want is a bunch of building blocks that can transform information into different forms. So we have something called